Hi there. My name is Sean Logue. This is my Jing for week 8 of the Data Structures and Elementary Algorithms class at Manchester Community College. So this week for our lab, we were looking at searches, linear search and binary search, but well, actually for the lab, we were only using linear search. You gave us 4 tasks, or rather 5 tasks to do. So you gave us a list for class, a bunch of numbers in a text file. So just to run you through my code. Start out, I just wanted to do a linear search, make sure I understood how it worked. And pretty much that's it. I feel like I've already actually used this, which was weird to kind of revisit it, but think of it in terms of linear searches. So that was just to make sure that a list could be, I knew how it functioned and everything, I could make it work. All of my, I put the different tasks in different files just to see independently how quickly I can do them, but each one of them features the same bit of text, which is opening the file that you have for us, reading that in, and then putting each line as a number in a list called array for some reason. I don't know why I did that. So yeah, this basically just fills the array with a bunch of numbers. All the rest of the tasks operate off of that array. So I have this function which is get the range. It prints the max of the numbers minus the minimum, which is the range. And when I did that, I got 79,013, which makes sense because the largest one was about 90. I think it was 99,999 minus about 20,000, which would make sense. Let's see here. Oh yes, also so. Step 2 and 3 of the lab. Step 2 was to find the most common number, I believe, and step 3 was the least common, or maybe I have that reversed, but it doesn't really matter. What I did is I used some different lists, and then I iterated over the list called array, and if the number was in the list called once, then, or sorry, if it wasn't in the list called once, it would add it. So every number originally gets added to this list. Then if the number has already been added, meaning that it's a duplicate, then it adds it to twice. And then on this last loop, if it's in both lists, then it gets added to a third list. Now, I just kind of had this idea because I was kind of curious how many I would come up with. I figured it would help me find the answer. Maybe I would guess, and it would be, maybe 3 would be the maximum number that would be in there, and that would be one way to figure it out. When I did it, it turns out that I got a pretty large list for once, and then a pretty large list for twice, and none went into the thrice folder. So it looks like the least common would be, well, whichever one is shorter. I'm not really sure. Actually, now that I think about it, well, actually, no, that's not what you're asking. Sorry. The least common number. There's many. They're all in the file only ones. Most common number. There's many of them, basically. And I know this code right here shows that every single number would be added to the once list, meaning that it would have numbers even if they repeated later. My file here fixed that. I can show it to you right before the end of it. Then the last step was to print the whole list without duplicates. This is actually the same thing as the once list, because this basically takes every number in, and then if that number appears more than once, actually, so it wouldn't be the same. Sorry, I just finished this, so there's probably something I didn't get through, but either way, this should take care of it. I found this online. If you do the set, then it prints the list without duplicates. And then lastly, you asked for the time length. Step 1 and 4, when I did them in independent files, were basically instant. It showed it right away. Step 2 and 3 took 1 minute and 41 seconds. So that was actually really long. It kind of makes sense. I think it's proving your point that it's going to take a long time. Now, I don't know. I know you were, like I said, your point was kind of trying to show how long linear searches can be, especially on unordered lists. So it's possible that I did 1 and 4 wrong just because they were instant, but I definitely see what you're saying with step 2 and 3. So I won't show you 2 and 3 just because it takes so long to even produce a result, and it's kind of hard to decipher just because it's such a huge amount of numbers. But I can show you I can show you steps 1 and 4. So if I open step 1 just so you can see, step 1, oh yeah, to get the range. So the range of the numbers right is 79 or 79,013. Then step 4, and this shows this. It's I don't know why this goes so far down without anything, but this would be the range, or sorry, this would be the amount of all the numbers without duplicates. And I'm just seeing now, I didn't realize it before, it actually puts them in order, which is actually really interesting. I did not know that. Okie doke. And yeah, like I said, this is the code for steps 2 and 3, just sort of isolated, spaced out a little bit. And this is where I remove all the numbers from the once list if they show up in the twice list. So anyway, I completed everything. I don't know if it's exactly how you wanted it. I hope this comes out well. It's the first Jing that I feel like I've done in like 3 weeks. So anyway, yeah, thank you very much for listening, and hope you have a nice night. Thanks.